Jeff walked through a couple of things around vision, and actually before we get PowerPointed to death, thought it might be interesting to kind of ask the room a couple of questions around, what's your perception today? You've heard 5 minutes of Jeff kind of talking. What's your perception today of CommVault? When you think of CommVault, what do you think of? Anyone? Backup? Right. Yep. So, anything else?
Mail archiving. Got one customer doing that. Mail archiving.
Okay.
Again, backup, as you said, but
Yep.
there hasn't been, at least in the channels the people I follow, I haven't heard a lot about CommVault in recent years.
Haven't heard from us in recent years. Okay.
Maybe, but now that you have Robbie, I'm sure we're going to be hearing a lot more.
Indeed.
This guy might be able to fix that problem.
Yeah. Okay. So that's actually three pretty common comments that we hear, right? When we walk into whether it's a customer environment or show floor. Okay, you have backup guys, right? One of quite a few now. What used to be 3 or 4 is suddenly, a tremendous number. More recently, yeah, you guys can do some archive and some interesting things around that. And the reason I kind of open that up is that one of the points of a chart like this and the pitch that Jeff kind of walked through is we think of ourselves as world-class backup, absolutely. And in a second, I hope to convince you of some of those things. But we really think of ourselves more as holistic data management from any secondary tier of storage. Right? So we're really trying to position ourselves as
a raised eyebrow from me is a compliment.
as really trying to set ourselves up as the software approach for managing a customer's data environment, at least the secondary tiers of data. So backup tiers, snapshot tiers, we're going to talk about snapshots, archive tiers, DR copies, all of those things, but manage it holistically and with a single software-based approach that's built from the ground up. Right? And when it comes to the comments around customers, what they're hearing from us, or maybe not hearing from us recently, is really around what we're seeing is customers are recognizing that the value of having that single approach and having all of that data under management opens up not only use cases for protection and archive and retention and recovery, but as we're going to talk about it a little bit, access. So can I access that data? Can I do stuff with that data, right? A lot of customers, once they have been through this idea of, okay, I've got all of your data under management, what else can I do with it? If you think about it, a lot of that data, we keep it around for a long time and it sits in a recovery tier or a retention tier. But it kind of sits there until there's a recovery event, right? Well, what if we can extract additional value out of that? Can we start to access that data? Can we start to share that data? Can we start to be intelligent about analyzing what's in there? So I just want to kind of plant the seed of that for some of the rest of what we're going to see. So when it comes to a protect standpoint, I just want to kind of take a few points around where we've gone from version 9 to version 10. And really it's all about positioning ourselves in the enterprise for scale. So when it comes to the number of clients, right, massive increase there in terms of the number of clients that we're being able to manage. That second one around concurrency, right?
Okay, could you
define please.
CommCell?
Yeah, thank you.
Oh, great. Okay, so CommCell.
Like a core.
That's what I'm afraid it is, yes.
You're afraid of what?
A reference to bad architecture from yesterday.
Oh, got it. Okay, so the CommCell is the core intelligence. It might make sense to do a quick whiteboard at this point to just kind of architect out the key kind of components of sort of what makes up CommVault. I think it might work.
We'll whiteboard if you have to. But basically, a CommCell is a domain of operations. If you think about it, if you have it depends on the customer side. Different customers have it configured differently, geographically, business distribution, whatever. Basically, it's a unit of operation.
Its associated media servers?
It's a little bit more than that. But if you're looking at only the backup context, yes.
Okay,
But basically, it's a domain. It's a domain of operation, effectively what it is.
fine.
Right, which has a whole bunch of entities, which has a whole bunch of data movers, which has a whole bunch of snapshot engines, and which has a whole bunch of indexing nodes in there.
Okay,
Right.
that's good enough.
Cool. Thanks, Z. Cool. So when it comes to concurrency, so having the ability for simultaneous users to go in and run restores or access those jobs. So what we're trying to do there is just continue to scale out the environment. This is kind of forward-looking to scenarios where we're sort of think of it as eliminating the help desk when we do restores,
User
things like
interface
that.
doesn't require Java anymore?
Well, so
Web 2.0 is HTML5, right?
I'm sorry.
Web 2.0 is HTML5.
Yeah.
Correct.
Thanks for
Yes,
that.
correct. So it's all web-based reporting.
So we'll see in a
Web-based
second, but
access.
what we're trying to
Yep.
segregate out is the user interface. The Java interface still exists, but that's existing only for the operators and the admin type users who have to do the basic policy management configuration and all that stuff. The vision here, as Phil laid out, is going forward, we do not want IT operations to be the undelete department. So we want to be able to provide users access to their data no matter which tier it is sitting in. Right? If it is in primary tier, they have access to it. If it is in tier 2, it's tier 3, tier 4. In the cloud, they need to be able to get access to the data, and the best way to give them access to that data is through a web console that is tied in to the role-based access that's already built into your organization. So you use your security credentials, log into this web console over here, and then basically any data that you have access to is available to you as part of the web console on your laptop, as part of one of those mobile devices that you carry, or as part of one of those tablets that you have over there. That's why the number of connections is a huge, huge scale advantage for us, because if you're talking about admins, you probably have 10 admins at the same time. If you're talking about end users that are actually accessing the repository in the back over there, you could have hundreds and thousands of them not only accessing it, but also running jobs that is pulling data in, pulling data out. Which is why the ability to have thousands and thousands of concurrent connections to the same comm cell is a huge scale advantage that nobody else can match at this point.
Okay, but can you please drive a big wooden stake through the heart of Java?
But 3 billion devices run Java.
Well, they can do it through their use of Java. I mean, I don't mean Java I do mean Java in general, but I'm not making them responsible for that.
Okay, got it. Okay, so when it comes to workloads, expanding those pieces out, I'm going to continue on off of this slide because I think we spent. So the first area that we sort of want to dig into is start talking about snapshots. I'm not going to take you through the slide. I'm going to assume everyone here kind of just raise your hand if you disagree with sort of the great benefits of snapshots, which are fast, efficient operations, rapid recoveries, granular recoveries, as opposed to Go ahead.
I don't think we disagree.
Yeah, okay, thanks. Right. So, but the point here of this sort of snapshot approach that we're taking is trying to marry the benefits, these benefits of hardware-based snapshots with the catalog and the retention and the long-term retention and recoverability capabilities of backups, right? So folks may be familiar with our feature in our product called IntelliSnap. And so the IntelliSnap capability is what makes this happen. So it is essentially our approach for managing heterogeneous hardware arrays from the software perspective. So we'll go up into applications, and in a minute we'll walk through a sort of an example, but we'll quiesce applications, quiesce VMs, manage all of the front end there. Then leveraging our IntelliSnap capability, we can drive hardware-based, array-based snapshots underneath the covers across, at this point, 19 out of the top 20 storage arrays in the industry. So EMC, Hitachi, NetApp arrays, all the Dell arrays, Equalogic and Compellent, that full list. As well as a very robust set of applications from VM, both Hyper-V and VMware. Exchange, SharePoint, Oracle, all those good applications there. So the point being here, we can get in and deliver those fast recovery copies, get in and get out with a very fast, quick snapshot copy, but then start to drive backup and protection operations or retention operations in the background. And to kind of help illustrate this a little bit more, I'm going to ask my friend Z to kind of walk us through it a specific example of how IntelliSnap is working.
Right.
Yep, go ahead.
So before we get into the whiteboard, I'm going to do a specific example on Oracle. And it could be on any storage array. But if you look at at a high level, what does Intellisnap bring? Because if you talk about snapshot management, there's a bunch of vendors out there that will claim that we do snapshot management too. The difference here is the ability to integrate with the application, not just from a backup perspective, but from a recovery perspective as well. Not only the ability to integrate with the application to drive snapshots, but the ability to integrate with the application to drive things like log backups, transaction log backups, and so on and so forth, and use a combination of hardware integrated snapshots along with the streaming log capabilities to provide a very short recovery point objective and recovery time objective. So here's an example. If I had a 5 terabyte Oracle database, right, and I was trying to protect, or I was trying to do a 15-minute RPO on that using traditional streaming methods, what would you do? You would basically have once in a week or once a day a streaming backup job that would dump the Oracle database to a very efficient target in the back end over there. But at the end of the day, I'm reading 5 terabytes from the front, moving it off to the back, and then deduping it or whatever. And then I have a 15-minute archive log process going on, right? So it's all well and good to create the backup process, but from a recovery perspective, there is no way you can guarantee a 15-minute recovery time over there. Why? Because it's a 5 terabyte database that needs to come back first. And you all know 5 terabyte takes a hell lot of time to bring it back.
And then you got to play those logs forward.
And then you got to play all those hundreds of logs back, right? So you're talking about a database that essentially will take a few hours to recover, be usable over there, right? So with this Intellisnap approach over here, what we're basically saying is I'm going to take the best of hardware resources that are very available to me, combine it with the application intelligence that's already built into the data protection IDA for Oracle. So here's what we do basically is you would have Oracle iData agent that has Intellisnap enabled. And that same Oracle IDA, I have RMAN backup or archive log backups running every 15 minutes. So when I run a backup job, let's say I do it every 2 hours. What happens is the job kicks in, it wakes up, it talks to Oracle, it puts it in backup log mode, or in backup mode, or in hot backup mode. As soon as it's in backup mode, the Oracle database thinks, yep, it's done, it's ready for backup, right? At that point, a traditional application would start reading all the data using RMAN and dumping it off to the back. That's where Intellisnap goes in, detects the hardware storage LUNs that are on which the database files are stored. It goes back in, it talks through the host, queries finds out the WWN, finds out the device ID, whatever it needs to find, communicates with the storage array, and at that point says, storage array, you need to go create a very fast hardware snapshot. Once you do a hardware snapshot, it comes back and says, yep, it's done. It takes a few seconds. Application comes back and says, my backup is done. I can move on, right? So that's your very fast 30-second recovery point, and it's all sitting on the storage array out there. And then you have your 15-minute archive log going on anyways. When it comes time to restore, you go back into the console, right-click, pick a point in time, and say, I want to recover to this last archive log job that was run 15 minutes ago, right? But that requires to first bring the database back. How do you bring the database back? We don't go back in and stream everything back. We just go back in, mount the snapshot, do a revert. Present that mounted LUN back to the database host over there, and then from that point on, replay all the archive log files. So literally, it's an operation that instead of taking hours and hours, takes a few minutes to come back to. So this is how you use a combination of hardware snapshots and archive log traditional methods to basically get for what is a very large database that traditionally you cannot ever get a 15-minute RPO or a 15-minute RTO. You can use a combination of hardware snapshot technologies as well as archive logs to drive that. And that's what we mean by application intelligence. It's not just the ability to create hardware snapshots, but it is the ability to index the application context over here to be able to say, if I have to recover this app to this particular point in time, I know exactly all the pieces that are there that I need to pull together. So I go in, I revert the hardware snapshot, bring it back online, replay everything back online, and then your application is ready to go in 15 minutes. So that's what we mean when we talk about the power of IntelliSnap over here, right? And it's the same thing in the VMware environment too. I can essentially take the same methodology and basically go back in and do thousands of VMs in a few minutes. And we'll talk about that in a second when we do the VMware protection thing over there.
Okay, thanks. So I want to kind of switch gears a little bit and talk about data deduplication. So when we launched version 10, CommVault launched our 4th generation of deduplication. The big change here from version 9 to 10, for folks, I should probably just backtrack and set the context of version 9 dedupe, and we'll talk a little bit about some of the details there. So SourceSide deduplication, global deduplication, all built in, includes, and we'll talk about some capabilities we refer to as dash copy and dash full capabilities. I'll show you what some of what that stuff looks like in a second. But with version 10, the big piece we've done here is start to introduce a more scalable, more resilient architecture for data deduplication. So in version 9, where we had essentially these individual nodes that we're able to dedupe up to 120 terabytes, we've introduced a concept called parallel deduplication, which is the ability to federate multiple dedupe stores together in a single grid. Right? We can marry that with our media agents. So in a CommVault architecture, the data movers, the media agents, and the dedupe databases we have the ability to architect the media agents in a grid capability, as well as now in version 10 the deduplication databases too. So we have the ability to fail over media agents. This is we refer to as our grid store technology. Fail over media agents, fail over dedupe databases now, as well as scale those things out. Right, so we can operate those dedupe nodes, those data movers in a parallel mode or resilient mode to go back and forth into failover. Right? So I want to just kind of throw out.
No, it's not important. Screw it.
Any other opinions?
You ask it.
Is dedupe ratio important?
Dedupe ratio is important, but dedupe ratio is also important relative to cost.
Sure.
That, if you guys can dedupe 80% as well as data domain does
Yep.
for 40% of the cost,
Yep.
then I'm happy to have another couple of shelves of 7,200 RPM drives in my data center. And the variation in dedupe ratio can be astounding. Mm-hmm. I did some research, and one of your erstwhile competitors
Yep.
tried to convince a major university that they should get rid of their data domains and install their appliances. And so the guy transferred, he had 30 days of Exchange backups, and he knew how much real space that took on his data domain. And he got an appliance that had that much real space from the erstwhile competitor, and started running net backup jobs to copy the data. And 10 days, after copying 10 days of backups, he got, repository full. So it was at least a third as efficient, no better than a third as efficient
Yep.
as data domain was.
Yep.
So it's important within reason.
I love that answer because it actually tees up a couple of sort of key things that we wanted to cover. You brought up cost, and relative to it, this is one of the values of sort of the software-based approach that we have. So because we can write to heterogeneous disk, at that point we can, like you said, introduce low-cost SATA JBOD. We can, there's not that requirement for like-to-like if we need to copy, in a data domain context from primary dedupe site over to a secondary DR site. Just leverage those disks. So the concept of does a dedupe ratio that's a little bit less, that's 80% relative to 90%. Well, if you're using those low-cost commodity disks, well, the cost is actually, and we're seeing this in lots of customer environments where that's the economics of that software-based approach actually work tremendously in our favor.
Now,
Yep.
I will call you on the 80%, 90% that you just used.
Okay.
Because when you say, well, it's only 80, they get 90% data reduction and we get 80% data reduction, that's only a 10% difference.
Yep.
That's actually you need twice as much disk difference. Because it's not the amount you reduced that you need to buy disk for, it's the leftover that you need to buy disk for. It's not the difference between 80 and 90, it's the difference between 10 and 20.
So let me take your point and then extend it out to the approach that we're sort of advocating and why maybe that lower dedupe ratio that may on this, what I'm going to say on the surface appear like it may be adding more disk, but what we're seeing in customer environments because of we have a capability now called dash full, which is, so with dash full capability, we now we can introduce an incremental forever strategy. So a lot of vendors are out there talking about incrementals forever. The big challenge with incrementals forever is that at some point, with most of the competitors out there, most of the vendors out there, at some point you have to run some sort of synthetic, right? You got to readjust and essentially rehydrate all that stuff.
Yeah, well, I mean, the truth is I want to run some incrementals forever, but I don't want to keep my data forever. And at some point, you got to run a throw away the data I don't want to keep anymore job.
Yep, right, true. So with an incremental forever approach, you run into those limitations of in the dedupe database, I've got at some point recapture all that stuff so that I can kind of recapture a consistent state and then carry on from there, continue on with a dedupe operation. So we actually introduced this in version 9 and we're carrying forward and improving on in version 10. Our dash full capability allows us to eliminate that need for a synthetic full. So what we're doing is updating the hash tables and the pointers on the fly as we're deduping so that that continuous incremental is truly forever because it's all being updated in the dedupe databases in the hash tables. So and we've eliminated that requirement of at some point, a lot of solutions, it's a month, 2 months, whatever it is, at some point rehydrating and reestablishing a baseline. With this capability, we've seen customers in version 9 that have gone for a month, literally months or at this point years without having to do.
Well, I mean, eventually you have to do a garbage collection.
So,
Yeah, go, please.
so yes, so just want to get back to this one over here to say somebody said dedupe ratio is important, and our argument here is dedupe ratio is actually the least useful measure of effectiveness. Because if you think about it, when you get a high dedupe ratio, it's very easy to get very high dedupe ratio. All you got to do is a full backup every night. Right? I do a full backup every night, 7 days a week. I have a 10 to 1 dedupe ratio.
All that really matters is how many 4 terabyte drives I need to buy.
Right?
And how many dollars that's going to cost
But
me.
think of, and full backups every day is obviously an exaggeration. Let's look at weekly fulls, daily incrementals. In a week, 90% of the data changes. 10% of the data changes, 90% remains static, right? But if I do a full every week, I'm taking 90% of the data every week, reading it, sending it over the network if I can't do source, giving it to the target in the backend, and basically throwing it away. That's all I'm doing. And then if that's what you call a dedupe ratio, and if that's what you're making effective use of dedupe, if that's what you call effectiveness of deduplication, that's a false measure. Why? Because here's a fundamental problem. Why are you reading the 90% of the data that hasn't even changed since the last time you read it? Why are you forcing your production servers to spend a whole bunch of cycles and time and resources and disk resources to read all that data? Send it over your 1 gig pipe to your dedupe engine, have the dedupe engine throw it away, and only write pointers in the back. Only to get a high dedupe ratio, right? So the goal here is not to get high dedupe ratio. In fact, I should say your goal should be to have as low a dedupe ratio as possible. What that means is, if you have that goal, you are basically going in and saying, I'm not going to read data unnecessarily, I'm only going to touch it once, I'm only going to keep 1 copy in the back, and if that copy hasn't changed in the front, I'm not going to spend even a millisecond trying to process the data and move it to the back here. Right? So in that case, what happens to my dedupe ratio? It's 1, 2 is to 1, 1 is to 1. Is that a bad thing? No, because what's my disk footprint in the back? My disk footprint in the back is identical to what I would have if I were doing a weekly, full daily incremental. Right? So dedupe ratio from our perspective is a very false measure because it actually reinforces all the bad rules that have been plaguing backups for years to come, for years in the past, which is our read to do fulls, which stresses out your production servers, which stresses out your production networks, which stresses out everything in the front end over there. Our approach is touch the data only if it has changed. Touch it only once. If it hasn't changed, don't bother processing it because you already have a copy in the back. But when you do touch it though, collect as much information about it as you can, store it to index in the back end over there so you can do all your processing in the back end. Which is why when you look at whichever data set that we're talking about that supports it, files, emails, VMs, our approach is do incremental forever. Never ever go in and do a full. Do a full once, capture all the data. After that, only capture changes to the backend. Move it off to the backend. To your point, at some point I need to clean it up. What do I do in the backend there? I run a dash full. What is a dash full? It's a synthetic full. But what does synthetic full do? It reads the data and writes it back to the same disk or same target again. It's reading from the same target and writing back to the same target. If it's already existing, why are you reading and writing again?
Well, that's the advantage of having the backup engine do the deduplication.
Exactly right. So that's where all I'm doing is I'm logically creating a new image, updating the pointers in the metadata. The blocks on disk remain the same. Logically create a new image, the older pointers age out, the data doesn't age out, the pointers age out, and of course there are no references to the older data age out. So to us, that is the bigger benefit of having a deduplication engine, is to be able to minimize the production workload, minimize the effect on the network, and then take all the processing here in the back and do all of your traditional weekly fulls, daily incrementals, or weekly copies offsite, or whatever you have to do. All of that happens in the back end. The impact on the production servers is minimal. It's just a few seconds.
Okay, so are you saying that you're moving to a TSM-like model where incremental forever is the default and the more traditional full incremental is an option for people who don't trust it?
Basically it. So whatever data type supports or makes sense to do incremental forever.
Which is great for files.
Files, emails, VMs.
Okay, so well,
and NAS.
If we talk about Exchange,
Yeah.
Exchange doesn't really support incremental. Exchange
Right.
supports log file backups, and that means that I got to play logs forward, and that cuts into my RTO, and I don't want that.
Correct.
So, are you doing?
So for, like I said, so for Exchange, for emails, message level emails, files, VMs, NAS, we are recommending incremental forevers. For applications that don't support the incremental forever method, you would still do a traditional weekly full daily incremental thing. But even there, go back to our IntelliSnap conversations earlier. If I need a database backup just so I can recover to my last copy, I don't need to keep 30 days worth of database backups, right?
No, but you know, if we're talking about Exchange,
Yeah.
and you know, I need to keep a substantial amount of that data for a substantial amount of time,
Yes.
because users are idiots and they will call the help desk and go, I deleted this email 6 weeks ago and I need you to recover it. And if I don't have a 6-week-old backup, I'm not going to be able to do that.
But does it have to be a 6-week-old database backup?
Well, MAPI backups take forever.
No, I don't. If I do incremental forevers, they don't. Love to have this conversation with you.
Now it becomes prove it, and that's an offline conversation.
Exactly. I would love to have this conversation today evening over here. But my proposal here to this room is, going forward, dedupe ratio should not be the measure of effectiveness of any dedupe solution over here, because dedupe ratio imposes a lot more additional overhead. By designing for higher dedupe ratios, you are designing extra load and extra burden on your production servers and on your production networks over there, right? If you go back in and kind of do the whole incremental forever for files, for emails, for whatever it is, there are ways to kind of get to the whole database protection strategy as well, using a combination of IntelliSnap and logs and everything else in the back there, right? So this is what we mean by smart and efficient data management over here, right? It's not about just blindly going there and copying data from the front to the back. It's collecting information about that data and using that metadata to figure out what are the pieces that I need to collect and store in the back, and what are the pieces that I don't need at all, or what are the pieces that I need to keep for a very short period of time. Okay?
Cool. Yeah, so actually, I kind of want to go to a whiteboard at this point, since we actually haven't used it. I can't believe we got this far without it. But I kind of want to outline here around when you just broaden the conversation a little bit before. We've been talking about deep into dedupe ratios and things. I want to broaden things out a little bit. When we say global dedupe, right, a lot of vendors talk about the global nature of their dedupe. So I want to set some context around what we mean and how we're architected to support kind of a global dedupe environment, and what the types of use cases that this sets up for things like DR, or just any kind of offsite types of capabilities, as well as desktop, laptop types of backups, which you have capabilities for, and robo, right, remote office. So scenarios all around that. So if you think about the traditional architecture of, you got your central data center and some sort of remote sites, remote offices captured out here. So with a CommVault architecture, we can essentially deploy media agent, dedupe database out here. This could be sort of it could be an on-site type of an approach in one where we're essentially using SourceSide Dedupe from this remote office. And in this scenario, we're talking about an on-site backup with on-site recovery capability. So we're deduping. There's obviously workers sitting out here running backups locally to this to the media agent sitting out here. But what we can do is leverage SourceSide dedupe and dash copy, which is essentially teeing off of Z's conversation around incremental forever. The key piece that makes that happen is dash, right? So we can talk about dash a little bit more. But dash copy capability gives us the ability to just move the changed blocks, even if we're deduping here. At this point, we're just moving the changed blocks down. So essentially, hyper-efficient, WAN-efficient deduplication, or think of it as dedupe-aware replication, if you will, right? So from there, and this, just sticking with this scenario here, we can then go and again generate, and of course down in this data center, we've got another media agent, another dedupe database down here, combination of that. And at this point, if we wanted to start to generate second tier, third tier types of copies, down here, and again, just dash it. And again, just moving the changed blocks. And what we're doing here is updating the pointers and the hash tables in the dedupe database here, tiering it down to the data center, and then tiering it down again to secondary copies.
And so this is all hash exchange followed by data exchange?
Yep.
Yeah.
Yep. So it introduces the idea of, right, again, another copy across the WAN here to the DR site, right? And again, just updating as we're going. Always got to have a data mover here, right? So, and again, just moving those change blocks to that DR site. Okay. I want to come back to the DR scenario in a minute because there's some other cool things that we want to talk about. But so, sort of remote office. Guess I'm going from the ground up. Okay. So another scenario where, think of this as mobile workers, or all of us here, right? In fact, all the CommVault guys in the room, our laptops are all running a very lightweight agent backing up all of our laptops. This is leveraging, and so you could think of this as a bunch of these laptops out here all over the world as opposed to a sort of remote office. Or it could be a remote office where we don't want to have that on-site copy, because there's plenty of places where, and in fact, we're having plenty of conversations with customers who are saying, I've got 50 different remote sites, and it's a management nightmare trying to deal with the backups of each one of those things, especially if there's tape involved, right? Then we're talking about, is there an actual admin involved with that? Is there a...
Tape in remote offices is evil.
Yep, absolutely. I think we would agree with that. So great opportunity for us to rip out tape out of that remote office. And what we're doing here again is SourceSide Dedupe down into the data center. Could be from that remote office, or actually all the desktops and laptops sitting in that remote office, or all the laptops sitting, here, downtown on 6th Street, up in Round Rock, wherever those laptops happen to be.
Singapore.
We'll talk a little bit about how we make that laptop sort of protect capability happen. Because there's lots of questions customers ask now, okay, great, it's not SourceSide Dedupe is great, but you've also got to have a lot of bandwidth throttling capabilities in there, right? So we have a lot of intelligence in that agent designed to detect what type of network connection do I have, right? So if I'm at the airport, obviously that's a crap WAN connection. So it's actually going to pause the backup at that point, right? When it detects that I'm back in the corporate environment, back in my home office, okay, it's a good network connection, I kick it off again. Also has throttles for CPU cycles. So last thing you want is you're doing email, you're working on your files, and then all of a sudden a backup kicks off, right? That's the absolute killer for laptop backups. So we have throttling for CPU cycles that says once it's below a certain threshold, which you can set. I think on ours it's like around 5 or 10%. Once it gets above that threshold, the backup pauses, right? Now, I think if we get to that part of the demo, one of the things that we've got is you'll see that typically on average, those backups take 4 or 5 minutes. That's what we were looking at earlier today. For a full backup, or at least the incremental backup of all the data on that laptop, including all the changes that we made to this presentation in the last 3 hours. Yeah.
With the throttling, is it CPU limit? Because I found that when backups are running, it's actually disk access that's the biggest issue. So if I kick off a new app, it has to load it off disk. That's what actually slows things down.
Yep.
Rather than just because my CPU won't be anywhere near peaked, but it's sitting there just doing a higher wait clock.
Sure. Yeah.
I can't believe I'm saying this, but just give everybody an SSD.
Well, you have to talk to the
At the laptop level,
guys
we're talking
about that. Yeah.
$150 upgrade.
Yeah. Yeah. Yeah.
Now, that's going to take 3 years because you have to cycle all your laptops. But
Yeah. So my question was more around the throttling.
So yeah,
Is
so
it-
there's a throttle on disk activity as well.
Okay, cool.
So it triggers if there's so much disk activity, then yeah, you can throttle in that. You can throttle it based on whether you are wireless or wired,
Yep.
and whether how much minimum network you have. Once you have the minimum network, how much should you consume?
and
Wide
since they wrote
variety of
this
ways
code
to
20 years
control.
ago, there's probably still a dial-up option. But
Believe it or not, we still get those demands because this is one of those things where if you go into not the US or Europe, but if you go
John,
to
how much bandwidth?
Okay. So the laptop backup option, again, down to the data center, and then, of course, we're into that same scenario. So I think desktop, laptop. DR. So DR is a really interesting use case. I mean, we've actually, if you think about it, we've only gone halfway in a DR scenario at this point with what I've kind of drawn here, right? I mean, you've got an offsite copy, but now what? You're not ready to recover yet. So you've got to have capability here, and we've got essentially, options around scheduled restores, and I also want to mention a feature called Virtualize Me. You can read that. Virtualize Me is what that says, and I'm going to apologize for my ridiculous penmanship. But with the combination of scheduling the restore and then running an operation like Virtualize Me, I'll describe Virtualize Me. What this does is essentially run an automated P to V conversion. So it takes, typically this might be a system state backup, right, of the entire environment. And what that does is automates the provisioning. So if I've got a vCenter environment up here, and now in version 10, we've got support for Hyper-V on this side. So if this is a virtual environment over here, then I can essentially convert that backup copy, that DR copy, into VMs. So we have the ability to create the VMs in VMware or Hyper-V, populate those with the data, power on the VMs, and start running this.
Can I run them directly from the backup repository, or is there a copy stage there?
It's a copy.
Okay.
Yep.
So this is one of those things where MSPs really like. They have a whole bunch of service providers that are actually using this functionality as their DR as a service catalog, basically. The idea is you still do your backups on premise, just send a copy of your backup using Dash to our cloud over here in the back end. Something happens, or you want to do DR test, we're not going to stand up an entire physical infrastructure. We'll just do this on an automated basis for you. You can do your DR test and let it go. And for some reason, if you lose your data center, if you lose a bunch of servers over here, let's run this over here, virtualize me, bring it back up within a few minutes, and you can continue running your production operations here while you build your while you build your facility back. This is also a good way for MSPs to capture some of the market over there, to basically say, now that you've run this in your data center, in our data center, for a few days, and you haven't really seen any noticeable effect, why you're actually running it in your copy now? Let's flip it around. Let's use this as a production copy, and periodically we'll send it over to your network if you want to your data center if you want a backup copy over there.
So what kind of cleanup is performed on the virtual machine that results from the physical backup? Typically, once it gets virtualized, it's kind of dirty.
Yes, we have something that we'll talk about this later on in the presentation that will help to address that over there.
Okay.
Right? But that's a very good point.
Yeah. And RTO is going to be determined by copy time.
Correct. But even same thing, let's talk about, there are a couple of things that we will talk in a different context that comes back and addresses this as well.
Cool. Okay. The last thing I want to touch on, I want to really briefly mention it because I think hopefully we'll have time to get to the demo of this is, right, there's a bunch of, this looks like about 5 different steps, depending on how you want to count, 5 or 6 different steps to make all this work, right? It's a copy down to the data center, copy to a secondary tier, copy over, okay. So that sounds pretty manual, right? And yes, we do have scheduling options, of course, so these things can start to run at prescribed times of day, but there's still, right, some work to be done here. So in version 10, we've released something, well, it's not a brand new concept, but workflow automation. So I can write in a GUI tool, which we'll show you in a second, or at least later on in the discussion, an automated process. It's not a script because it's built in natively into CommVault, into the software that runs this whole process. So it kicks off the backup, confirms the backups, yes, run, kicks off the dash copy, make sure that that's run, kicks off the DR operation, confirm that that's run, schedule a restore, all in a single workflow type of an environment. So it's an incredibly powerful tool, again, one that a lot of our larger MSPs are starting to key off of. You know, the DR scenario is just sort of one environment where a workflow is pretty powerful. There's tons of others. You know, one example actually that I like to talk about is, again, the new user registration. So every employee, we actually are using workflows in CommVault to deploy our laptop backup solutions out to all of our users. So all 1,500 employees that we have now. Any new employee that comes in is issued a laptop. Traditionally, you know, you'd have to go and create storage policies, create clients, install the agents on the laptop, configure the scheduling, do all that. With workflow automation, it's a form. Okay. So, DR. Cool. Yeah. So, right, okay, virtual server data protection. So we want to switch gears now, and I may go back to the whiteboard again. But so, of course, you know, virtualization's a big deal. You know, we're now seeing most of our customers, I'd probably say, are about 80%, or 80% of our customers are running our virtual server agent. It's about what the attach rate is right now. And I think on the statistics we've seen, anywhere from 60 to 70% virtualized. So any given customer on average is running about 60 to 70% of their environment in VM. Thank you. That was very helpful. But it's probably useful to talk about our approach and our architecture to handling a VM environment. So if I just kind of cartoon out here a couple of, this is sort of an ESX layer with a bunch of VMs. Could be VMware, could be Hyper-V, right? We typically advocate a proxy. Man, my penmanship is terrible today. A proxy approach where we're going to install our virtual server agent, our media agent, and if we're running Intellisnap, hardware-based snapshots, we'd install Intellisnap in this environment, okay? And what we're doing is running auto discoveries. So, deep integration into each of these environments, run auto discoveries against against all the VMs we can discover based on VM, based on data store, based on ESX host, based on VM names. New in version 10 is the ability to filter VMs. So big question a lot of customers came up is, okay, I'm running auto discoveries based on data stores, but I happen to have one or two VMs that are very large or running heavy lifting workloads in that environment that I just don't want to have, kicking off with the typical backup. Or I want to do something different with those so we can filter those out. Right, so at that point, we're running, and this is where, we're advocating sort of a best of both worlds approach. And what I mean by that is, and that's why the reason I drew both a media agent and an Intellisnap agent here is obviously media agent is our data mover. So when we're running DDo backups, the media agent's involved. When we're running Intellisnap, this is driving snapshot operations on the array, right? So now if we think about, okay, I've got data stores connected down here. And if I just take an example where I can map a media agent here, where this is maybe sort of second tier apps, second and third tier applications here, and my primary data stores here, I want to map to an Intellisnap operation. So what I'm saying here is, for these tier one apps, these are things like Exchange, database applications, heavy lifting workloads, where either I have very fast granular recovery objectives, right? Recovery points around 1 hour, 2 hours, those types of things. And with capacities and change rates that are too high, a DDo backup approach simply can't keep up. So we're seeing a lot of vendors or a lot of customers are looking at trying to protect backup some of these workloads where it takes 2 days, 3 days, right? Even with deduplication, which gets you lots of benefits, it's just not fast enough. So we're advocating for these primary data stores an Intellisnap approach. One of the things that we've walked through in some of the presentations is going through for these primary workloads. One of the things we've seen is this is where we started to get into VM snap issues if we're running dedupe backup copies of these heavy lifting workloads, right? So because the change rates are so high, and when you create that VM snap, even if you're running, right, anyone who's running a VADP backup, relying on a software snapshot of the VMs, right? So then trying to stream off, even if you're deduplicating, streaming off the backups of all that VM data, typically that's sitting out there for hours. Meanwhile, the changes are building up in swap space, right, in that swap file on the VM, and that can take hours, right? And if you've got a very high change rate, the number of changes that then have to go and get reconciled back into the VM.
This is sounding familiar.
Okay, yeah.
Why don't you come in here and explain? That would be great.
So I sounds like, yeah, I won't belabor the point. So this is the value of snapshots. So what we can do with hardware snapshots is come in and completely change the game, right? I don't have to rely on the time it takes, even if it's 6 or 7 or 8 hours to run a deduplicated backup, when I can do a snapshot copy in seconds, right? So even though, and because I've got a snapshot copy, the time it takes to run that is so fast, there's very little data that's built up in that swap space. Right? This is a presentation we gave at VMworld last year. Maybe that's why it's familiar.
No, we were just having the VMware snapshot suck conversation with the previous.
Understood.
Can I-
Understood. Yeah, I wanted to throw out the, but go ahead.
But if I'm going to get an application consistent snapshot,
Mhm.
and I'm going to rely on a block storage system to provide that snapshot, then I need a dedicated LUN for this application. And that means, since I can only have 2048 LUNs, that I've got big scale problems.
So, yes and no. Number one, if it's a tier 1 application that requires all those IOPS and all the transactions, and if it's a block-based system, you are probably going to have a dedicated LUN for that VM anyways. It is very bad practice to have your high transaction VMs sitting on the same data stores as your low-end VMs over there. Usually there is always some sort of segregation there, right?
So, Bob, all your apps that you worry about snapshot resolution on are in dedicated LUNs?
Or if they are undedicated, the ones that are undedicated ones, share disk backend.
Well,
So that's-
just with a dedicated LUN, you can get a snapshot.
Oh, yeah, beyond that, though,
I was kind of enjoying that. Oh, yeah.
he's,
That's a good point.
Yeah, he's,
Right.
buddy,
So here's the thing. Even if you don't have dedicated LUNs, the point is you do not have to, even if there are VMs, other VMs that are sitting on that same LUN or same data store over there, you do not have to quiesce all the VMs to get a snapshot of the LUN over there, right?
I have to quiesce the app. I have to quiesce each app that I'm concerned about.
Right.
And if I've got a LUN that's got 2 or 3 of these apps, because if I've got a 3-par and I'm wide striping up the wazoo, or if I've got a storage system with a substantial amount of flash, your arguments about, you should have a dedicated LUN because the disks are being shared and IOPS go away. If I've got any of those kind of environments and I've got 5 SQL servers in one LUN because my DBAs get one LUN, it's easier to give them one LUN. Every time I want to take a snapshot of one of those 5 VMs, I have to take a snapshot of all 5 of those VMs because I got to snap the whole LUN. That system may only support some limited number of LUNs, and now every backup job's generating a snapshot. It's not your problem. It's
Correct.
an industry problem.
Exactly. So that's exactly right? So that's where we come back with and say, you got to figure out which VMs really deserve or require the snapshot treatment. That's where we have the ability to go back in and say, to your example, if there are 5 VMs that require the snapshot treatment, there may be 100 VMs on the same volume. But out of those, only 5 of those are my critical high transaction VMs over there. I can create a data protection policy that targets only those 5 VMs in a single job. So in a single job, I can go in and I can only quiesce those 5 VMs, right?
I would challenge that you could get those 5 VMs, 5 SQL servers to all quiesce in the VSS time allowed.
But I'm not creating all 5 I'm not quiescing all 5 at the same time. I'm just waiting for all 5 to quiesce before I take a snap. So the 10-second timeout is available only for that one VM, not for all 5. So I'm going in, I'm quiescing SQL Server 1. Once it comes back, it says I'm going to go quiesce SQL Server 2. Or I could do those in parallel, but they are 2 different VSS processes. So the 10-second boundary doesn't apply to all 5, it applies to just one. Now,
But at the end of the 10-second boundary, it stops quiescing and it starts doing IO.
no, it needs 10 seconds to quiesce it. Once it's quiesced, it doesn't go away in 10 seconds. It has 10 seconds to respond to the request and come back with a quiesce. The snapshot isn't held for only 10 seconds, right?
Okay.
So I can go in and I can drive a policy which says, I have this here's a data store that has 100 VMs on it, out of which 5 of those are really critical applications over here, and I need to create a snap-based copy of that. I go in, I create a backup policy that has those 5 VMs. I don't worry about the remaining 95 over there. When I run a data protection job, I will fire off. In 9, I would do one at a time. In 10, I can actually go fire 5 of them at the same time. Fires of 5 different VSS processes, or if it's Oracle, I can actually go and talk to the Oracle database inside, quiesce all of them at the same time. Only when those come back will I go back in and snap the entire LUN.
Okay, that's a step up.
So that way I can then go back and I don't worry about the remaining 95 VMs because I have another way of backing up those VMs. I go back in, quiesce those VMs, then I come back and now I still need to create a backup copy of that. I can then, and that literally takes a few seconds to a minute depending on how many transactions I have. Once that snapshot is done, I don't have to keep the VMware snapshot around anymore. I get it up, I give it up. So literally, I'm in the snapshot redo log only mode for maybe a minute at the most, right? And if it's a high transaction VM or if it's a large VM, the difference between staying in redo log mode for 1 minute while I'm doing the hardware snapshot compared to staying in the redo log mode for 30 minutes while I'm doing a streaming backup copy, that's a huge difference. So all of the issues that you see around VM protection of large VMs, which is hanging snapshots, snapshots not getting deleted on time. If it's a clustered VM, the cluster fails over.
Thank you.
I'm losing connectivity to those VMs. All of that occurs not because I'm not able to create snapshots, but because I have accumulated so many changes in my redo log over a period of 30 minutes that takes me forever to come back and reconcile those. But if I do the Intellisnap thing, I'm only connecting a minute worth of redo logs, go back in, and that redo log reconciliation is much faster. Then I can mount the snap at a secondary place and then do a streaming backup copy of that if I need to, for however long it takes me to. But I'm not worrying about my production storage, I'm not worrying about my production VMs over there. So that's what we're basically talking about here. What about the remaining 95 VMs that are part of the data store? They don't need the snapshot treatment. If I'm okay with dirty snaps, I don't do anything. I just take those, leave them in there. But if I do need a backup copy, that's where I go back in and use the tier 2 and tier 3 VM strategy, where I basically apply the streaming incremental forever methods. I go back in, I quiesce those VMs 1 at a time or 2 at a time or 3 at a time or whatever. I leverage change block tracking. Change block tracking in this case is highly effective because those VMs are really not changing that much. Small changes, I take it to the back end, and as we talked about earlier, if I do need a full copy, I run a dash full in the back end over there. So this is a huge differentiator from the point solutions that you have, where there is one approach and one approach only. There are several challenges, as we all know in this room over here, with managing snapshots on VMs. And if you have an approach that relies only on vStorage API and VADP, you're always going to come across 10% of these VMs that do not fall into the boundaries of these VMs over here. So your only choice is go back to your legacy data protection engine and put an agent inside those and continue backing up the old way. That means you have 2 solutions that are doing that over there. Or you leverage Intellisnap to drive that backup copy in the back end over there.
So can I clarify? So you take a snapshot, let's say I've got 50% of them need snapshots and the other 50% don't. Or let's say that, more importantly, I've got half of them, the timing is important, that I snap them at this time and these ones are at a different time. So I can do that. These ones are clean, these ones are dirty. After I've taken the snapshot, I can grab just the clean data
Correct.
and put it out? Okay, that's cool.
Correct.
I think this is where we want to kind of switch into a quick demo on.
What I'll do is I'll really quickly show you.
Quickly, right? Yeah. Okay. It's the first one. Yeah.
So this is basically an illustration of exactly what we're talking about. You need to be able to apply, and especially in an MSP type of environment where people are building different type of service catalogs and they're providing different types of service offerings from a backup perspective. You need to be able to create different backup policies for your different data sets over there, right? It's not I'm going to apply the same data protection policy for all the VMs and that is VADP streaming. Now, there are some VMs that will need a backup copy or a recovery point every 2 hours. And there are certain VMs that don't need a recovery point every 2 hours, but they are large enough that the streaming VADP method doesn't work over there. Here's an illustration of how you would go back in. I'm not sure how clear it is over here, but in the V10 context, this is where you would set up a virtual server agent. In this case, my virtual infrastructure is called vCenter, my vCenter 5. What I've created over here is lost connections. So what I've created over here, let's see if we can get this back, are 4 policies: gold, silver, bronze. Okay, great. All right, and I'll come back to this in a second over here. But if you look at it, I'm not sure if it's clear over here. The gold is basically pointing to a storage policy called VSA Gold, and it has dedupe enable. But that policy has snapshot enable, and then a backup copy is created from the snap. So I can actually have my gold VMs that are associated with my gold resource pool, or a resource pool associated with the gold SLA type customer, create a protection policy that's only for those VMs. And I'm not, and when I go in here, I'll actually show you. Let's put this on and bring it back. Are we still connected?
There's the whole connection. Is it just that one? Because you got 2.
Yeah, it's just that one thing.
Is the other one good? Because you can just go to it.
The network here dropped out.
Sorry?
Yeah.
The network here dropped out and it's come back again.
Yeah, we've actually been having a little bit of hiccups with the network. I'm sure people on the stream have noticed that. We're not sure what's causing it, but bear with the demo.
No.
Well, there's your problem.
That's the admin console. I don't like to call it the Java console.
Steak vampire.
All right.
So is the next version of the admin console going to be HTML5?
Potentially. Potentially. Let's put it this way: when you combine it with workflows and our end user console, you will rarely have to go to the admin console. All right.
Yep.
So if I look at my gold protection policy over here, right. So inside the content tab over here, you see that I'm not actually picking up VMs, because that's how usually most of the times in this type of service type environments, the VMs themselves are organized in different arms or different groups or different folders or whatnot. So we have the ability to attach directly to the folders over there. We don't have to actually pick those things. And this is goes back to the automatic discovery piece, where we don't have to go and figure out whether a VM is due or not. If it gets added to the appropriate group over there in the vCenter context, and we have a data protection policy that corresponds to that group, we'll automatically consume that VM and add it to our data protection policy. So in this case, I've tied this policy to a resource pool called gold. And if I look inside the Intellisnap option, all I have to do is go back in and check in the Intellisnap checkbox here. And then I pick the storage array that this data stores on. Right? That's it. No scripting required, no need to understand which SimCLI command to run if I'm using EMC. No need to understand what's the ONTAP command that's associated with NetApp, and what's the device manager command that's associated with HTS. All you got to do there is basically go down here, pick which storage array that data store is stored on, pick that appropriate one over there, and give the credentials to the array that is required to run snapshots, and that's about it. You don't have to do any kind of complex configuration from a snapshot perspective, right? When I run this backup job over here, first thing it's going to do is going to quiz all the VMs that are part of that gold policy, and then go create a hardware snapshot in the back there. Same thing on the silver policy. I have automatic silver policy where I have it configured against the silver resource pool, and the bronze policy where I have it configured against the bronze resource pool. But I don't have Intellisnap configured for those. So all I do is I have to turn the Intelliscam checkbox off because I'm going to be doing incremental forever backups on those VMs over there, on the bronze VMs. More importantly, I also have the ability to go back in if I look at my storage policies, and storage policies in the CommVault context dictate things like retention, things like how many copies you keep, and so on and so forth. If I look at the gold DDo policy, the primary copy is actually my snapshot copy. So what it basically means is when I run the backup job, I'm going to create a snapshot, and that snapshot is going to exist for 4 days. On the 5th day, when I run another backup job, the snap that I created 4 days ago will automatically get deleted. So you don't have to go back in and clean up all the snapshots over there too, because we know which snaps got created. We'll go back in and delete those. And then if I create a backup copy from that snap, it's going to go into this primary copy over here, which is a DDo disk, and that backup copy is kept around for 15 days. Right? So this is one of the most commonly used configuration with all of our service provider customers over there, is they tie all of their VM data protection policies to resource pool affinities, and then essentially they're creating configurations in the back end that match data protection policies to the service catalogs. Right? So they provide 3 different service catalogs and basically say choose which one you want to connect to.